The GTX 1060 was one of the most popular video cards, at least according to the Steam Hardware survey, for almost 5 years. But now that other models outrank it, and Nvidia decided to pull the plug on the game-ready driver support for it, does it mean that this card is now useless? Judging by the results from ARC Raiders, I'm going to say no, far from it. At low settings, the game experience was quite good. But we'll see later on if the performance in this title was just a fluke or the rule. As it became tradition, I will defer talking about the details regarding this card to the GPU-Z window seen on screen right now. Feel free to pause the video if you need to. I will mention, however, the 6GB of GDDR5 connected to the GPU over a 192-bit bus and the 120-ish watts TDP. For that amount of heat, MSI decided to use a similar thermal solution as the one used on the Radeon R9 290. A somewhat power-hungry card. So, we have 3 thick heat pipes contacting the GPU, then sending the heat to a consistent fin stack and a couple of 92mm fans that work in PVM mode. The video memory and power delivery dual MOSFETs are cooled by a metallic plate and the required thermal pads. To mount this beast of a cooler onto the video card, the PCB had to be enlarged. And while some, me included, will giggle at the rather empty board, MSI will probably justify that by claiming that the larger ground planes help with cooling. Because strapping a 1 kg worth of a cooler might not be enough for this power-hungry beast, and you need as large of a ground plane as possible. Fortunately, MSI's valiant efforts paid off, and the card maintained 66 degrees in games for a delta over ambient of 43 degrees Celsius. But this video is not a GPU cooler review, so it's time to check how the card itself performs. And to do that, we're going to throw it into our, by now, usual testing PC, a Ryzen 5 5600, 32GB of DDR4 running at 36MHz in dual channel, all on a B350 Tomahawk board. And as usual, we start with Marvel Rivals. I tested this title at low settings, and at 1080 resolution, the card averaged 65 FPS and managed 52-41% lows. Already playable performance for my level of competence in this game. Reducing the resolution to 720 has these two metrics rising to 115 and 92 FPS respectively. For Cyberpunk 2077, I wanted to find out the settings at which the card can still provide at least 30 FPS for the 1% lows. 1080 resolution and medium settings will get 40 FPS for the average and 31 FPS for the 1% lows. Somewhat similar performance can be obtained at 1600 by 900 and high settings, albeit with 2-3 FPS more for both average and 1% lows. 720 resolution and ultra settings get even better numbers, with 51 FPS for the average and 38 FPS for the 1% lows. My preferred combo, however, is 1080 resolution and low settings. The GTX 1060 managed 67 FPS for the average and 50 FPS for the 1% lows. ARC Raiders was tested only using the low settings preset. The average FPS that the GTX 1060 got ranges between 68 at 1080 resolution and 102 at 720. The 1% lows will go from 46 FPS at Full HD to 65 at half the pixel count. The game is perfectly playable, and there is really no reason to drop the resolution from native HD. Like with the previously reviewed GPU, I decided to test Counter-Strike 2 at 1080 resolution, medium settings and no FSR. I also left the anti-aliasing to 2x MSAA. One can tell that I was trying to avoid a CPU limit here. Anyway, the card clocked 231 FPS for the average and 110 FPS for the 1% lows. The goal of testing control is to find a preset where the GTX 1060 reaches at least 30 FPS with the 1% lows. Apparently, this is 1080 resolution and high settings, where the average FPS was shy of 40 and the 1% lows managed 31 FPS. But you can drop the settings to 1080 medium, and you'll get 51 FPS for the average and 43 FPS for the 1% lows, with little loss in visuals. Just like with the previously reviewed GTX 980, I decided to switch to medium settings and the DirectX 12 renderer to test the Pascal GPU in Fortnite. I tested at 3 resolutions, as seen on screen, and the average FPS ranged between 103 FPS at Full HD and 156 FPS when dropping the resolution to 720. The 1% loss for the same pixel counts were between 71 FPS and 109. Doom Eternal is quite VRAM sensitive, and 6GB will allow the GTX 1060 to go as far as 1080 resolution and ultra settings. The card managed 97 FPS for the average and 73 FPS for the 1% lows. This is fine, even for this rather fast-paced single-player game. Similar requirements of 60 FPS 41% lows apply for Apex Legends, an online competitive shooter. Fortunately, the GTX 1060 can hit that at low settings for all three tested resolutions. Depending on the pixel count, the average FPS can go between 184 at Full HD, all the way up to 280 FPS at 720 resolution. It's worth noting that the card will hit the internal 300 FPS cap at the low resolutions, so the numbers collected will be affected by this. Anyway, the 1% lows will range between 129 and 187 FPS for the same pixel counts. In the case of Far Cry 6, my setup did not allow me to find the settings combo where the 1% lows barely managed 30 FPS. The card does better than that, and 1080 resolution and ultra settings had the GTX 1060 averaging 53 FPS. The 1% lows stayed above 40. The results for Overwatch 2 are as expected affected by the internal FPS cap at 600. At 1080 resolution and low settings, this is not much of a problem, but the numbers for the low resolutions do not scale with the reduced pixel count. Anyway, the card averaged between 335 and 593 FPS, while the 1% low spans from 242 FPS at 1080 resolution to 461 FPS at half the pixel count. Since Resident Evil 4 is a single-player title, the aim of testing is to find the preset where the 1% low still manages 30 FPS. In this particular case, 1080 resolution and the balanced preset, but with FSR disabled, seems to be it. The Pascal card averaged 44 FPS and the 1% low stayed in the low 30s. For Rainbow Six Siege, I tested only 1080 resolution and low settings. The GTX 1060 manages 104 FPS on average and 80 FPS for the 1% lows. This is perfectly fine for what I can actually do in this game. But if more FPS is needed, maybe dropping the 3D scale to 50% is the better option, since the built-in upscaler is quite decent. You then get 159 FPS for the average and 121 for the 1% lows. Borderlands 3 is another single-player title, so the aim here is to keep the 1% lows above 30 FPS. The GTX 1060 managed to do that at 1080 resolution and badass settings. The card got 41 FPS on average and 34 FPS for the 1% lows. Robocop, however, is a bit more demanding. The card does manage 30 plus FPS for the 1% lows, but only at the low settings preset. The average FPS was 43 and the 1% low stayed in the mid-30s. FSR quality can improve the performance though for limited impact on the visuals. You'd get 54 FPS on average and 44 FPS for the 1% lows. Keep in mind though that the game does not require sharp reflexes. Unlike the previous two titles, the Finals is an online shooter, so the demands are higher. 60 FPS for the 1% lows is a good start, and fortunately the GTX 1060 can handle it. At 1080 resolution and low settings, the card averaged 99 FPS and got 74 FPS for the 1% lows. Back to single-player titles, Shadow of the Tomb Raider managed to run above 30 FPS for the 1% lows when using the GTX 1060. I used the canned benchmark, and at 1080 resolution and higher settings, the system managed 61 FPS for the average and 45 FPS for the 1% lows. Terminator Resistance is the title to close the benchmark section. Based on the now older Unreal Engine 4, the game can easily run at 1080 resolution and epic settings on the GTX 1060. The card averaged 85 FPS and the 1% lows got really close to 50. To me at least, it's quite clear why people loved Pascal cards so much. There was progress felt at all performance classes, and a lot of that progress was passed to the consumer. The 60 class was no exception, and included an increase in the amount of video memory, but also a notable increase in performance. So, understandably, the 1060 remained a favorite for quite a while. But the extra weight added to the card does rub me the wrong way. The 110 watts TDP R7370, also from MSI, can use a lighter cooling solution, ending up with a card that weighs about 630 grams. For 10 more watts or 9% increase in TDP, the GTX 1060 ends up slightly above the 1000 grams, or about 50% increase in weight. That extra weight only adds extra stress to the PCB and the lead-free solder balls that connect it to the GPU, something I mentioned also with the GTX 980, making them more likely to crack. And you can easily tell that the 1 kg of a cooler is overkill because MSI felt comfortable to add a 0 RPM mode to the fans. Again, overkill, and if that trend continues, then the next stop is going to be something even more ridiculous, like a 3-fan cooler on a 50 class card. Back to the 1060, it can be found nowadays for less than 100 USD, typically at 60 to 70. And for this price, it's not a bad deal. But just like in its heydays, the main competitor is the RX 580, and it will go for similar prices or sometimes cheaper. Granted though, at the settings used for testing, those 2 extra gigabytes of VRAM will likely not make much of an impact. Anyway, that's about it for the GTX 1060. Thank you for watching, I hope you liked it, and I'll see you for the next one.